Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of derivatives. Now here we are with the next set of questions, question number 13 onwards. You have to find the derivative of this inverse trigonometric function, which will reduce into a simple function just like the previous one where we had a minus x divided by 1 plus ax. So once again the same formula that we will apply here. So what about this derivative of tan inverse of root x minus tan inverse of root a, correct? So tan inverse of x minus y divided by 1 plus xy, this can be written as root x into root a, correct? So that is like tan inverse of x minus tan inverse of y formula. So now differentiate this. Root a is a constant, tan inverse of root a is a constant, derivative of a constant is 0. So just differentiate this. So let us differentiate it. What is the derivative of tan inverse x? 1 by 1 plus x square. So 1 divided by 1 plus, in place of x we have got root x. So root x whole square into derivative of root x. So this is tan inverse of root x derivative. Now derivative of root x is 1 by 2 root x. Alright, and derivative of this is 0. Just simplify this, you will get one of these options. So let's see what we get here. Okay, so this is 1 by 1 plus x square. Square and root cancel, so 1 by 1 plus x, I am sorry. And here you have got 1 by 2 root x. Well, so which is the right option? Option D is the answer, 1 by 2 root x into 1 plus x, that's it. Alright, so that's a easy question, just you have to identify that tan inverse x minus y formula. Alright, so tan inverse x minus tan inverse y formula. So that is tan inverse of x minus y divided by 1 plus xy. Well, let's move on to the 14th question. Alright, look at the question number 14. If f of x is equal to, once again, inverse trigonometric function tan inverse of under root 1 plus sin x divided by 1 minus sin x. Now you have to try to get tan here, so that tan inverse of tan will reduce into a simple form, correct? So 1 plus sin x can be written as you have done this. You have done this in your board syllabus, okay, in ITF, inverse trigonometric function chapter. So let me just revisit that. So tan inverse of you have got under root cos x by 2 plus so cos x by 2 plus sin x by 2 whole square. And what about the denominator? That is cos x by 2 minus sin x by 2 the whole square, right? So that is about substitution. Now look at this. This is a plus b whole square. That is like cos square plus sin square, which is 1, and 2 cos x by 2 into sin x by 2. That is sin 2 into x by 2. That is sin x. So you will get this 1 plus sin x if you expand. Alright, similarly when you expand this, you will get a minus b whole square, therefore you will get minus over here in place of 2ab term. Okay, I am not going into detail of this, you have done this already. Now square root and square will cancel out, and you will be left with the cos x by 2 plus sin x by 2 divided by cos x by 2 minus sin x by 2, okay, and reduce this into tan. Therefore divide by cos x by 2, you will get 1 here. This is 1 plus tan and 1 minus tan, correct. So then 1 should be replaced as tan pi by 4, okay. So we will do that, but if you know the shortcut formula, then directly you can substitute tan pi by 4 plus x by 2. So this is tan pi by 4 plus x by 2 formula. Well, I will show you how to get it. In the exam you have to write the answer directly, you have to save your time, so remember that. See, what is this? Tan of pi by 4 plus x by 2. Okay, so divide by cos x by 2, you will get 1 plus tan x by 2 divided by 1 minus tan x by 2. Okay, next you have to write tan pi by 4 over here, and then substitute okay. So this is equal to tan inverse of, in place of 1 what are you going to write? Tan pi by 4, tan 45, and this is tan x by 2 itself divided by here 1, and this is 1 into tan x by 2. So this 1 should be replaced by tan pi by 4 and tan x by 2, correct, because 1 is nothing but tan pi by 4, tan pi by 4 is 1. Well, now this is like tan x plus tan y divided by 1 minus tan x tan y, which is tan of x plus y. So this is like tan pi by 4 plus x by 2. Well, now tan inverse of tan, you will be left with only the angle, so pi by 4 plus x by 2, which is still f of x, right. Now what you need to find is f dash of pi by 6. So let us find f dash of x first. Okay, so what is f dash of x here? Derivative of pi by 4, derivative of a constant. So derivative of a constant is 0, correct, and then 1 by 2 is a constant as it is, derivative of x. So this is half into x, correct. So half into x. So derivative of x is 1. So that is half itself. Now what will be f dash of pi by 6? F dash of x is half. What is derivative of, what is f dash of pi by 6? In place of x you have got pi by 6, but you don't have x there. You cannot substitute pi by 6 anyway. So that half itself is the answer. You don't have to worry about substitution here. You cannot substitute at all. Alright, it can be anything. It need not be pi by 6, pi by 2, pi by 12, or whatever you have, any angle you have, 0 degree, 20 degree, 15 degree, anything. Answer is always half. Okay, so half is the answer of f dash of x as well as f dash of pi by 6, or f dash of any angle is half. Well, so that's for 14th question. Let's move to the next one. Alright, now let's move to the 15th question, which is based on exponential and logarithms. Alright, so here we begin with the exponentials. So derivatives of exponentials and logarithms. What is the derivative of e power x? Alright, so derivative of e to the power x is e to the power x itself, and derivative of a to the power x, like 2 to the power x, 10 to the power x is constant. So that is like a to the power x into log a, and then derivative of log x is 1 by x. So that is derivative formulas. And what about e to the power log x to the base e? So that will be only x. And what about log to the base e power x? That is also x. So e and log are opposite functions. Okay, you can think that they'll cancel out each other and only x will remain. Here also log and exponentials are opposite functions. You will be left with only x. Okay, so those are the formulas you have to remember, and all other formulas of logarithms which we have done in preliminaries of algebra. Okay, please recall those formulas. We had solved many questions of logarithms there. Okay, so those formulas are very handy here in finding the derivatives of functions involving exponentials and logarithms. Well, so having that knowledge in the background, let's start with question number 15. Alright, so question number 15, you have got y is equal to e to the power. What I'll do is I'll shift that half instead of writing the question again. Okay, so if you have anything before log that goes as the power, correct, remember, okay, that will shift here. I'm not going to repeat that formula, please go back and check that video. Okay, now e and log, see, if you don't write any base, it means that the base is e, and e and log to the base e are opposite functions. They will cancel out each other. You will be left with only 1 plus tan square to the power half. What do you mean by to the power half? Under root, square root of 1 plus tan square. And what is 1 plus tan square? Secant square, and that is y. So root and square will cancel out, and you will have only secant x. So that is about y. Now you need dy by dx, right? So you have to find the derivative of y with respect to x. So differentiate secant x. What is the derivative of secant x? Secant x into tan x, which is option C. So option C is the answer. 15th question was very easy if you know the logarithmic formulas and the exponential formulas. Well, let's move to the question number 16. Alright, let's begin with the 16th question, and you have once again exponentials here, so differentiate with care. Now first, derivative of sine. Derivative of sine is cos into derivative of y. So derivative of y is dy by dx. Please don't forget this. Whenever you have y implicit function, you have to differentiate that as well, and then you have got e power. Okay, so e power u is e power u, the derivative, so that will be same, but there is something extra. What extra? Derivative of minus x cos y. So minus x as it is, derivative of cos y is minus sin y, into derivative of y is dy by dx. Alright. Okay, next derivative of x cos y. Let's continue. First function as it is, derivative of cos y plus cos y as it is into derivative of minus x. Derivative of minus x is minus 1. That is about derivative of e power minus x cos y. Now, what is the derivative of e power 1? Derivative of e is a constant, 2.7128, something like that. Alright, so that's a constant, so derivative of e is 0. Well, please remember that. Now, what are we finding? Dy by dx. You see that here as well as here. Okay, so take that common. So for that thing, you can simplify, or else what you need to find finally is dy by dx at 1 comma pi. That means when x is 1 and y is pi. So you have to substitute 1 here and pi here, you will get the answer. So you can go for simplification, or you can just substitute and then simplify. Either way is fine. So let me take some time to simplify. Okay, if you want to save some time, then you can go for substitution. Well, so this is minus and minus, so it will be plus itself, x into sin y, and then e to the power minus x cos y. So that will be dy by dx, and this is minus cos y. When I take to the other side, becomes plus cos y. So I got and this has to be multiplied. So this is e to the power minus x cos y, because this has to be multiplied inside here as well as here, then that full term I am taking to the other side, and now this term has to be divided here, but I am not going into that step. I will substitute. So at 1 comma pi, what happens to this? So this will be cos pi. What is cos pi? Cos 0. Okay, so cos 0 is 1. So at pi it will be minus 1 on the negative x axis. Alright, and plus you have to substitute 1 here. Okay, and sin pi is 0. So this full term becomes 0 there. Okay, which I will do in the next step. And this is 1, and cos pi. So cos pi or whatever, this part will be 0, so hence the full term is 0, and then dy by dx, that's equal to cos pi, which is minus 1, and e to the power x is 1, and cos pi is again minus 1. So let me simplify. Cos pi is minus 1, and plus this full term is 0 because sin pi is 0, and that is dy by dx on the outside, and cos pi is minus 1, and e to the power minus of minus 1, so that will be minus e, and here you have minus dy by dx. So what is dy by dx? It is e, and option C is the answer. Option C is the answer. You can guess just by looking at the question. Why? Because there is no chance that you will get sin y, because y is pi. You got to substitute there. Okay, so you got to substitute. So options cannot be in terms of x and y. Options cannot be in terms of x and y, because x and y values are given, right? So substitution has to be done and final answer has to be attained. So this is very basic question. Just by looking at the question you can decide that E is the answer. Final answer should be in terms of in a real number. Okay, you should get a definite value there. This is not a definite value. This is variable. As y changes you will get different values. This is not a fixed value. This is not constant. Okay, a constant must be the answer. So only option C can be the answer. Okay, but still we have to verify and understand, therefore I had to explain this, otherwise we could guess the answer just by looking at the question. Well, so that's for question number 16. Now let's move to the next set of questions.
Don't forget to like our video and subscribe our YouTube channel for all the updates.